like, "Are you supposed to get involved?" And she goes, "Well, you're sitting right behind me, bitch." And I'm like, "What is wrong with you?"
I was like, oh.
She was like, yeah, I don't understand.
Probably get started.
Is Alex supposed to be? Alex is right here. The other. For you? You gave some money?
You need to start bringing a pencil sharpener to school.
I remember when you gave me that eraser. I still have it.
It's a good eraser, that's why.
Yeah.
Try it. Come over today and see if just walking
That's what Marina thought.
you want 2 dimes? She's not that good. It's like the rapper we used to have in public separate. Yeah, he's like a rapper. It's exactly how I make my raspberry. Because I put a lot of sugar.
Or else she goes like, "Oh, what's her name?" That's a lot of good. I thought Sammy, yeah. Sammy was my favorite. Why don't you have two? I don't have one either. Where are you going? Yeah. Sophie, is there a problem?
I didn't get the answer. Where? I couldn't find it.
We're done. Done.
Oh, I actually don't like this.
Okay, let's get started then, everyone. Thanks. Thanks. Okay. Okay.
Very fast.
Oh, yeah.
Okay, so the idea here is you're going to need to find totals. Okay. So let's get some totals across. How many people went to see Jurassic Park? 35.
We're going backwards.
How many people went to see Lethal Weapon? Is that 35 again? How many people went and saw Gone with the Wind? 30. That's great. That's a total of 100 people. That's nice. And then we can total how many people in all ordered pepperoni? 43. How many people ordered ground beef? 32. 22. 35. Okay, so without the totals, you kind of can't do anything. And that kind of takes care of... No, it doesn't take care of anything. The next thing you want is the... Well, you want to turn these into, in the first case, a marginal distribution. So let's take that same table. We're going to copy it over. And we're going to do the marginal distribution of pizza toppings. Okay, pizza toppings are the columns, right? So if I want to do the marginal distribution of the pizza toppings, I have to know what percent of total is the first topping. What percent is the first topping pepperoni? Well, that's 43 out of 100. That's 43%. If I want to know what percent of total is ground beef, the other topping, then that's 22 out of 100. 22%. Lastly, what percentage here are the mushrooms? So that's 35 out of the 100 total, and that is 35%. So if you want to find the marginal distribution for the toppings, then you need to divide the topping total by the grand total. If you wanted to find the marginal distribution of the movies, then you need to divide a movie total by a grand total. So maybe I should make a notation here. The what did I just say? The marginal distribution of pizza toppings is equal to pizza toppings total divided by grand total.
Marginal distribution for toppings.
Okay, and that takes care of that one. Next, compute in percents a conditional distribution of pizza toppings for each pizza, or for each movie. So let's do that again. That's 43%, that's 22%, that's 35%, that's 100%. We're going to need to do some comparison, so I'm going to leave that there. So we want a conditional distribution of toppings for each movie. Is that what I'm reading?
Yeah.
Yeah. So again, you need to take a topping divided by total for the movie. So for example, Jurassic Park would be 20. That's the topping for Jurassic Park divided by the total for Jurassic Park. That gives me 57%. Next, I want to take that ground beef and I want to divide it by the total for Jurassic Park. So divide that by 35 again. That's 14%.
Oh.
Okay. We want to know the conditional distribution of mushroom in Jurassic Park, for Jurassic Park. 10 divided by 35. That's 29%. What did I just do? That makes this 100%. Okay. You have to read it. Okay, so you know what to divide by. We need to divide by for each movie. That would implies a movie total.
Okay.
Given a movie means you divide by a movie total.
So it doesn't matter if it's your percentage or decimal.
No, as long as you're consistent.
So like let's say for part A we did decimal, we should do decimal for the whole.
Yeah.
Are we gonna be picky with the rounding for percentage? Like if we do decimals in it, is that okay?
No. This is one place where the rounding is not quite as well
It
defined.
would be okay if like this one I use instead of like a 57.1%.
Yeah, it's fine. All right, let's do the same thing for lethal weapon. That's 8 out of 35. That's 23%.
Yeah.
Okay, for lethal weapon, that's 15 out of 35, which is 43%. And lastly, 34%.
So we're gonna have to keep remaking the charts for each section, right?
This is 50%. I don't need a calculator for that one. Of course, it's going to give it to me anyways. 50%. That's 2 out of 30, which is 7%. And lastly, out of 30, that's 43%. So that's the conditional distributions of toppings for each movie. Think about it like this. You want to figure out how are the toppings distributed for each movie. Why would you just divide by the total for a topping if you want to know how the toppings are distributed for the movie? A good, careful reading of it should let you, or should inform you about what you're dividing by. Just don't go into it blindly and figure out what is going on. Yeah.
For part B, the one is that you need to do the total 42%, 22%, 35%.
The total?
Totals.
Like.
Oh, over here?
No, the bottom.
No.
Oh.
That's just for my own information right now. Okay. Actually, that's going to be for part C. So let's take a look at part C. Yeah.
So in part B, if it says compute the percent conditional distribution of each movie for pizza toppings, then you would do it the other way?
Yeah. So for part C, which ones are preferred greater than the marginal distribution? Okay. Well, let's take a look at that marginal distribution. Okay. Here, pepperoni, we expect each movie to be around 43%. As you notice here, there's actually a huge range of numbers here. And the two that seem to prefer pepperoni more than 43%, more than the marginal, are Jurassic Park with 57% and Gone with the Wind at 50%. So Gone with the Wind, or pepperoni, is more preferred by Jurassic Park and Gone with the Wind. Okay. How about ground beef? Which one of these are greater than 22%? Yeah, just Lethal Weapon. So ground beef is more preferred by Lethal Weapon viewers. And let's see the same thing here. 35%, 34%, that's too close. 29%, that's less than. 43%. So mushrooms are more preferred by Gone with the Wind viewers. And remember, we're comparing it to what we would expect. We would expect Gone with the Wind people to prefer, we expect about 35% of all Gone with the Wind people to have mushrooms on their pizza. But actually it's 43% of all Gone with the Wind people. So Gone with the Wind seems to prefer mushrooms more than we expect. And that's kind of the essence of this. What do we expect? What did we actually get? For us?
Why did we expect it to be more than that?
Well, we expected 35%. because our marginal distribution is 35%. When we found our conditional distribution, we found that 43% of Gone with the Wind viewers preferred mushroom. Same thing here with Gone with the Wind and pepperoni. We expected only 43%. What we got was 50%. So that's more than we expected. Adam, and then
Isn't the 35% just of all the toppings, like of all the people watching all the movies, that 35% of the time all of them take mushrooms, and then of that 35% of the time people who watch Gone with the Wind will take it 42%?
it's not a percentage of a percentage.
Okay. Okay, it's like inception.
Yeah.
How can we tell that, like, how big or how low or how high does it have to be for you to say that there's something that,
I'm saying as a rule of thumb, like 5%.
so then, since like ground beef and Gone with the Wind is 7% and marginal is 22,
Yeah,
don't all of those seem kind of far, so you can't really determine that?
they do. They do.
But if there's some kind of thing
And
that
yeah,
breaks
yeah.
it-
And I think what you're seeing here is the effects of Lethal Weapon, because 43% is much greater than 22%.
So Lethal Weapon just inspires you to have ground beef.
So what?
Lethal Weapon inspires you to have ground beef.
I imagine something about buddy cop movies makes you want to consume ground beef. I don't know. Do people even get ground beef on their pizzas? Is that even a topping?
It is.
It is? Ground beef? Okay, how about less than the marginal distribution? This is really the same question, but kind of the flip side of that.
It's basically giving the recipe.
Yeah. So let's see. Are any of these less than 43% by more than 5%?
Lethal Weapon.
Yeah, Lethal Weapon. Okay, so Lethal Weapon.
So if it's within a range of plus minus 5%, then don't think it doesn't count.
Lethal Weapon viewers. I'll get to your question in 1 second, okay? Prefer
Pepperoni.
pepperoni much less than expected. Okay? How about for ground beef? Does anyone get ground beef in less than 22%?
Jurassic Park and Gone with the Wind.
Jurassic Park and Gone with the Wind, yeah. Okay, so Jurassic Park and Gone with the Wind viewers prefer ground beef much less than expected. Maybe I should just say less than expected. And remember, when we say what we expect the marginal distribution. How about for mushrooms?
Jurassic Park. Would you say Lethal Weapon, even if it's 0.7% lower?
Well, it has to. The rule of thumb here is about 5%, and I don't think 34 and 35.
So
That's
on
too
the-
close.
On the test, make it 5%.
I would say within 5% would be expected.
All right.
You would expect to be within 5% of 34, which is what, 39 and 29%, somewhere around there. 29% is kind of cutting it here. So what are we saying? Mushrooms. And Jurassic Park. I guess all the meat-eating dinosaurs inspire them to eat meat. Jurassic Park viewers prefer mushroom toppings. Less than expected.
So within 5.
Within 5%, yeah. It's pretty close. Okay. Any questions?
I think you might have put 16 right above it by accident.
Where?
I know, but I think like up more,
Mm-hmm.
you might have labeled it as number 16.
It is.
No, it's free response question. Yeah,
Oh.
right there. So people don't get confused.
Wow, I made it.
Well, if you're at home looking at this, you probably would be like, oh my god, what the hell, I can't study. Now I'm going to show up late to the test.
Free response question. Okay.
I understood, obviously. You know, what's your
Can you go for 1 second?
Sure. How far up do you want?
A little more. Yeah.
Good?
I like stats.
Okay. One more thing. Make sure when you're comparing your marginal and your conditional, you're comparing the correct marginal numbers and the correct distribution, or the correct conditionals. So if we're dividing by the row total, then for your conditional, for your marginal, you need to also divide by the row total. So notice all the 100% here are on the right. That's what you want to do. Okay? Letter D. Letter D. D. Okay, let's go to 16. Okay. 16. A 3. Huh? I think that's a typo there. A 1969 study among the Pima Indians of Arizona investigated the relationship between a mother's diabetic status and the appearance of birth defects in her children. The results appear in the following two-way table. Let me get this. Let's go ahead and just reproduce this then. We have higher, the same, lower. Wow, sorry. We have non-diabetic, pre-diabetic,
And
diabetic. And of course, we're going to want the total column. None. 754, 362, 38,
Giving us a total of 1154.
31, 13, 9. Okay, so let's do some prettiness. Okay. Oh, I forgot we need another column for total. All right, did I hear the 1154? Great. That's going to be good. You're going to want to compute that anyways. Might as well figure that out now. 53?
Yes.
53. Great. Let's get our totals. 785. 375. 47.
Grand total of 1207. No problem.
Great.
Why is this? This is not never. This is never.
They're all up.
Okay, so compute in percents the marginal distribution of birth defects. Okay, so we want the marginal distribution of birth defects, so we want to divide by a total number of birth defects. Why do I have an extra row here? We want the distribution for birth defects. We should divide by the totals for birth defects. Is birth defects still the terminology they use?
Yeah.
I would imagine they would have PC'd that up.
Would it be birth defects in children?
It's better than retard.
You don't want to call children defective.
It's better than mutation.
Yeah, it's better than like mutated or
Actually, what do they call these?
Okay, so let's get that. We want to divide by the totals for birth defect.
Yeah, can we call them mutants instead?
Oh, sorry. We should divide the totals for birth defects by the grand total. Okay? Thank you. Divide the totals by the grand total. Okay, so let's do that. So that's 1154 divided by 1207. That gives me 96%. That should be 4%. And of course, that's going to be 100%. Great. So basically, what that means is, if I'm going to look at the non-diabetic mothers, then we would expect to see this is about 96%, this is about 4%. If there's no relationship between the diabetic status and the number of birth defects. If there's no relationship between the diabetic status and the number of birth defects, then we would expect to see this is about 96% and this is about 4%. And similarly, if there's no relationship between being diabetic and the number of birth defects, this should be 96% and that should be about 4%. They already look bad.
Right. When making the marginal distribution chart, is it necessary to repeat all the numbers, or would you just write none, one, or more total, and then right next to it write the total percentage?
But the thing, I think what you're seeing here is like this is kind of like an incomplete chart. So we're just kind of completing it one step at a time. Okay, so this would be probably the only chart we'd need for part B. So for part B, we're going to divide this by yeah.
You don't have to do like the column, like marginal distribution. If that makes sense, like non-diabetic.
We did the marginal distribution right here.
Wait, so you don't have to do like 785 by 1207?
Only if it asks for that one.
Oh, I didn't. Okay, I just did.
Divided by 785. Oh, no.
So there's no relationship if they match up relatively.
Yes. That is absolutely correct. Hey, look, 96% again.
That's pretty good.
Go non-diabetics. So that should be about 4%, right? That's 4% right there.
Part,
We're now on part B. Okay, and if there's no relationship here, then when I divide 362 by 375, I should get a number close to 96%. Let's see, divided by 375. Yeah, 97%. That makes this 3%. So again, 97% compared to 96%, that's what we expect. There's no evidence to support right now that being pre-diabetic affects the number of birth defects. Okay? However, if we divide this by the column total, we get 81%. That's much less than we expected. If we divide this one by 47, which is the column total, we get 19%. Which is much, much greater than we expected. Okay. So what does this mean?
That if you're diabetic, you'll combat one or more birth defects.
Yeah. This means that there seems to be a relationship between diabetic status and number of birth defects. Namely, mothers who are diabetic tend to have more children with birth defects than expected. And you wouldn't know what to expect unless you looked at that marginal distribution.
For this one, would you put that although the population size isn't as great as the other two, it still affects it?
You know, that's information that
Is unnecessary.
not that it's unnecessary. That's something for somebody who is going to study this more in depth.
Yeah.
That's something that they would look at. Someone who's just kind of looking at the chart and making decisions about the chart wouldn't necessarily need to make those decisions just yet.
You want to be objective.
Right. You know, since the numbers are very off here, we're talking about 754 versus 38. There's a really good chance that there's some kind of a Simpsons. Was that Simpsons? Simpsons paradox.
Are we getting tested?
Not in this test. But it's possible that there's some kind of Simpsons paradox at play here. Possible.
I think there is, just because it's such a low population compared to other ones, that it creates that kind of.
Well, remember, Simpson's paradox implies that there's some other variable that's being unaccounted. What would that variable be? I don't know. I'm not studying this, you know. Yeah.
For part B, would we put the total percents for where it says 75 or 75%?
Yeah, we would put 100 there.
Oh yeah.
Oh, it's C? Is there a D? No part D, okay.
Whenever it comes to putting the total for the percents, you can tell which area you should put the totals for based on wherever we add up to 100, right?
Yeah. Whatever you're dividing by is 100%.
Okay. So if we wouldn't need that column all the way on the right, the total going up and down.
You wouldn't need this marginal distribution. I'm sorry, no. You don't need this marginal distribution
Oh, we don't need
if
that.
you're using this marginal distribution.
How do we know which one we're supposed to do?
It'll tell you. Okay. Any other questions? I'm gonna kind of wait for you guys to deal, because we're good? Okay. The other one that we didn't deal with here is question 13, I think. Yeah, question 13. Let's look at 13. Okay. I'm prioritizing the ones that are not on this already. So you know. We're just prioritizing what has yet to be done. Yeah.
Did you say not on the what?
Not on the study guide already.
Why is that number
This is 14, right?
one? Yeah.
Okay. So let's look at 13. Recycling is supposed to save resources. Some people think that recycled products are lower in quality than other products, a fact that makes recycling less practical. People who actually use recycled products may have different opinions than those who do not use recycled products. Shouldn't that be use them? Oh, A. I don't know. There's a double Y also. That's misspelled. Here are data on attitudes toward coffee filters made from recycled paper. Recycled paper coffee. Okay, let's make this chart all over again. We have higher quality, the same, lower quality, and the total. $27 and $9. That's 36. It's not a very big sample. Non-buyers, 29, 25, 43, 80, 94, 97. And totals, 49, 32, 52, 123, 133, 133, 50, 80, 120, 129, 131, 133. Good. Okay. Give me a second to set this up nicely. Right. So that takes care of all of this. Part A. Find the marginal distribution about quality. Okay. Quality are columns. So I want to divide column totals by row totals. Quality quality are columns. I need to divide column total by the grand total. So let's do that real quick. Feel like I'm gonna need more room. Let's make more room. That should be enough room. Okay, let's make that chart again. We're gonna divide that by 133. We're gonna divide that by 133. We're gonna divide this by 133. And we're saying this is 100%. So that's 37%. This is 24%. This is 39%. Okay. Assuming that these people represent all users of all coffee filters, what does this distribution tell us? Well, this should tell us that, well, I don't know. If there was no relationship between users of recycled product and opinion of quality of recycled products, we would expect both buyers and non-buyers to have a conditional distribution of opinion similar to 37%, 24%, 39%. So if there was no relationship, we would expect to see that for both buyers and for non-buyers. How do the opinions of buyers and non-buyers differ? Use a conditional distribution as the basis of your answers. Okay. Well, let's see. Let's take this chart again. Let's get all of our conditional distributions this time. Oh, jeez. I don't know. Okay. If there was no relationship, we would expect it to be the same. Same as a marginal distribution means no relationship. So that this is going to be 20 out of 36. Sorry, I forgot to write down 100% here. That's going to help me know what to do. So 20 out of 36, that's 56%. 7 out of 36.
Wait, what number are you on? Like, A, B?
We're on B. I'm going to need more room again. Okay. That's 56%. That's 19%. That's 25%. Okay, so let's see. Is there anything that's not within 5 percentage points? Clearly here, buyers think that recycled products are higher quality than we expect. Okay. Let's do this one over here. Divided by 97. That's 30%. Divided by 97. That's going to be about 26%. Divided by 97. 44%. Okay. So, people who already buy recycled goods, they seem to think that well, we would expect 37% of them to say that recycled goods are of higher quality. Actually, 56% of them said that recycled goods are of higher quality. It's really hard for me to think up here. I don't know if you've ever tried it with a bunch of teenagers like gossiping in the back. It's really not cool. Don't have to be here. No, use your time wisely. Okay, this is 56%. That seems to be much greater than 37%. So buyers of recycled goods, let's just say more buyers, think recycled goods are of higher quality than expected by the marginal distribution. This is kind of 5%, so you could say something here, but it's not that necessary. This one is probably necessary. We were expecting 39, we got 25. So also, buyers of recycled goods who think recycled goods, this is so wordy, are of lower quality are less than expected. Is less than expected by the marginal. So it seems like this entire thing is shifted more toward higher quality opinion. How about for non-buyers? Let's see. We expected 37% of them to say that recycled goods are of higher quality. We only got 30. We expected 24% of them to say that they're the same quality. We got 26. That's really close, actually. We expected 39%, we got 44%. That's 5%. Better listed anyways. So non-buyers, more non-buyers think recycled goods are lower quality than expected. I'm phrasing this wrong. What do you think? Non-buyers who think recycled goods are of lower quality are less than expected. The percent of non-buyers is less than, there we go. Okay. The percent of non-buyers who think recycled goods are of higher quality is, did I mess that up? I messed that up, didn't I? Okay, so the percent of non-buyers who think recycled goods are lower quality is greater than expected. So we expected 39, we got 44. This is greater than expected. This is less than expected. We were expecting 37, we got 30. I wish this wasn't such a wordy thing, but that's what it is. Okay. So, it seems as though buyers tend to think that recycled goods are of higher quality. Non-buyers tend to think that they are recycled goods are of lower quality than what we would expect. Does that can you conclude that recycled filters causes more favorable opinion? No. We've shown that there's a relationship between buyers and opinion, but this doesn't mean there is a cause and effect relationship. Causal relationship, that's the word we have. Yeah.
So even though like the non-buyers have lower opinions of the higher quality recycled and higher opinions of the lower, like you can't say, like, because like basically if you gave them it, they probably would say like the buyers that is of like the higher, like agree with that.
I wouldn't make that relationship. I wouldn't say that it's a cause and effect relationship necessarily.
Because there's just not enough evidence to support that.
Yeah.
Is that because the marginal distributions are so like close?
It's a combination of that, and this is all, this is not from experimental data. This is just, looking at the survey. Okay. How about it's observational but not experimental?
So if it's like a experimental question, then you could make that assumption.
you would have a stronger case.
Okay.
Yeah.
It's kind of off topic, but can we go over relationships?
The three of them?
Yeah, the three of them.
Yeah. We could do.
That was kind of off topic. Well, it was about the
Okay, so I think that covered everything that is not already on this. So I'm going to take a short pause here, okay? We've been at it for 55 minutes. 2 questions.